In the last video we saw how to use new. We saw that this is something that is a simple allocation of a single int is something you never want to do. Alright, so don't put that in your code anywhere. I don't think there's any good reason to have something like this ever. We saw a situation where you would want to use new, that is when you want to allocate memory on the heap. And also we saw that whenever you see a new, it doesn't have to be in the same method, but somewhere you want to see a matching delete. For every new, you have to see a matching delete. If you don't, then there's a good chance that you're gonna allocate memory and not deallocate it, and that would mean that eventually your program, if it runs long enough, would run out of memory, would use up so much memory that it would crash from not having any more memory to allocate from. Okay, so new, even if it's not in the same function, somewhere else you have to have a matching delete. Alright, so I just want to show that it's not just arrays that you can use new for. So let's say we have a class. So I'm going to set up a simple class C, and let's have an int data member, int x. Remember, it's private by default. Now let's say you want to pass in not just an array to this process function, but a pointer to an object, and you can do that. You can say ABC. You can say star. Remember, whenever you say star, you're saying pointer. Okay, and now we no longer need this int function. What I'm going to do is I'm going to go back to this. I'm going to create a new overloaded process function, ABC star. Alright, and I'm going to call the compute function, and now instead of an int star, I'm going to say ABC star is equal to new, and here's the thing that we can do. We can say ABC, just like in Java, call the default constructor, and this is also memory allocation from the heap. Alright, so I'm going to get rid of all of this, and I can call this process, overloaded process function with a as the argument, and then I will just print out a. And I don't need a loop anymore because I'm not dealing with an array. Instead I'm dealing with a single object. And here we no longer have an array, so I'm going to take out this delete key and delete keyword, and I'm just going to delete a itself. So this, although you probably don't need to use objects like this, this is how you would use objects with pointers and use the new function. So this way you allocate memory. If you want, now the thing that a points to will be around well after you exit from this compute method. Now the alternative to using new, we have seen this before, is to have something like this. I'm just going to actually take this out and say A, B, C, B. Alright, this allocates memory on the stack. This allocates memory for the thing that A points to. That memory is allocated from the heap, and you can pass it into a function like process, do stuff with process, and you can return stuff if you want to. And then eventually, wherever you see a new, somewhere, it doesn't have to be in the same function, you have to have a matching delete, or else, let's say this ABC object has a massive JPEG image in each instance, which takes, let's say, a megabyte. If you have 1,000 of those, that's easily a gigabyte, and if you don't deallocate memory for each one, if you have 1,000 of those ABC objects, you might use up a significant chunk of your memory. Your entire system slows down. So in order to deallocate memory you no longer need, you have to have this delete, a matching delete for every new. Alright, so now let me just set up just something to satisfy the compiler. I'll set up a process function that's overloaded to take a pointer to this object of type ABC, and we don't actually have to do anything with it. Alright, so assume that we do something, doesn't matter what. Alright, let me see if I can get this to compile. Alright, we're lucked out, everything compiled. So this is how you would use new with classes. And you can do the same thing with structs too. And you might want to try this, print out something, assign, put some methods in there, and run this. So for structs versus classes, really no difference. We print out what we're actually doing is printing out a pointer to an object. So that's why we get this memory location. Okay, and one other thing let's do the same thing with class just to make sure. I don't think we actually ran it, so this time I'll compile it and run it. Okay, all right. So a simple illustration of how to use new with a class. Or as you saw just minutes ago, you can also use structs. You can allocate you can set up a pointer to a struct or a class, allocate memory using new, do stuff with it, and then finally you want to be sure that for every time you use new, you have a matching delete. Alright.